Assalamualaikum and hi, I am Mazlan bin Ahmad Mansur. And everyone, my name is Haiqal Dzarif bin Ramli and my partner is Muhammad Hakim bin Basir. Today we are going to talk about frame and machine. Okay, let's move to the structure. This is the actual structure that I have found around my house. The structure is backhoe. This is the approved structure by our lecturer I am Mazlan. Okay, the structure can be divided into four systems that exist, but first of all, we need to know that what is frame and what is machine. The frame is to support load and the machine is contain moving parts and designed to transmit and alter the effect of forces. Okay, by understanding frame and machine, we can analyze that each of the system whether it is frame or machine. For example, the biggest part of the backhoe is the arm. The arm is frame because it is used to support load. For another example is the BE member. The BE member contain moving part, so it is machine. Same goes to frame. That is the second frame is bucket and the CB and BA member which is machine because it has moving part. Okay, now let's continue with free body diagram. The free body diagram, me and Hakim has discussed and come up with this final free body diagram. For example, here FHI is going to the left down, FBE to the right down, FCB to the right down. Same goes to the bucket here. As you can see, FBA is going to upright, DX right, DY up, and W to down. For CB and AB member, we assume both member experience tension force. Therefore, the arrow at both end of each member is going out from the member. For the member EB here, we assume also it experience the tension force. Okay, now let's move to the calculation. Okay, there are given value here. FHI equal to 9 kilonewton, FBE 7 kilonewton, DX at 2 kilonewton, and FX 1.5 kilonewton. For Fy equal to 1 kilonewton. And we need to find FBC, dy, FBA, and total moment at F. Okay, first of all, we need to look at the FBD and to understand where are the X and Y component of each force going. For example, for FHI here going to the left. So I put here negative FHI cos 40 plus FX to the right plus FBE sin 10. FBE here, the x-axis of FBE is going to the right. So I put here plus FBE sin 10. And FBC cos 40 because for the for the x component of FBC is going to the right also. And for the dx is going to the left, so I put here negative equal to 0. And I find the answer of the FBC here. I got the answer is 8.07 kilonewton and the force experienced by the FBC is tension. Okay, now let's move to the equation of y component which is equal to 0. So first of all, Fy going to upward, so positive. FHI sin 40, y is going to downward for FHI, negative sin 40, negative FBE cos 10, going to the down also for y of FBE, and negative FBC sin 40 going down also. So negative FBC 40 minus dy because dy going down and equal to 0. Then I find the answer of dy is negative 16.87 kilonewton, or we can say that the dy have the magnitude of 16.87 kilonewton going downwards. Okay, now find FBA. Okay, I have analyzed the free body diagram. Then these three free body diagram. Okay, I have come up with this simple free body diagram at point B. As we can see here, FBE is going out from the B point. B point here, B point here, and B point here are joined at one point. Therefore, I assume the FBE is going out because the FBE from every member is going into the point. Okay, same goes to FBC. the force is going outward, and FBA going outward from the point. Okay, now let's move to the X component with at point B. Here, as we can see here, negative FBC cos 40 because FB negative is going to the left because the tendency of X component of FBC is going to the left. Same goes to FBE sin 10 going to the left, and FBA cos 30 going to the left also. Then equal to 0, I calculate the answer, I got negative 8.54 kilonewton. And we can understand that if there is negative here, so the force is compression. Okay, now I express out the y component, y equation, then equal to 0 also. FBE cos 10 positive here because FBE is going to up at y axis. Cos 10 plus FBC going up also at y axis. Sin 40 minus FBA sin 30 because FBA is going down at y axis. Then equal to 0. Then I calculate the answer for FBA is 24.16 kilonewton. Okay, here are some difference between two answer because this one is compression and this one is tension. Okay, after I study the overall part of the backhoe, and then I found that the AB must be tension for the logic one. So I accept the answer for FBA is 24.16. Okay, now let's find the moment at F. Okay, so first of all we need to see the FBD here. Okay, where is point F? Point F is right here. Okay, then I assume that if the rotation is going to clockwise, then the direction is positive. Okay, first of all, negative 0.7 FHI cos 40. Here 0.7 cos 40 because 40 cos 40 here for x axis of FHI. So the tendency of the rotation is going to anti-clockwise. So here I put negative. Then for the y component of FHI is here going downward, and the distance is 0.15. So the tendency to the rotation is going clockwise. So I put here positive 0.15 FHI sin 40. Okay, for the FBE here, cos 80 here is for x component of FBE. So the x is going to the right, and the tendency of the rotation at point F is anti-clockwise. So I put here negative 0.5 FBE cos 80. Okay, let's go to the sin 80 of FBE, which means y-axis that is going down. Then the tendency of the rotation is also clockwise. Okay, so the distance is 0.5 here, and here I put positive because the tendency of the rotation is clockwise. So plus 0.5 FBE sin 80. Then for the FBC, cos 40 here for the x-axis. Cos 40 is to the right. Then the tendency of the rotation is anti-clockwise. So negative 2.5 here, and times FBC cos 40. Okay, for the y component, the direction is going to downward. So the distance here 0.3, and the tendency of the rotation is clockwise. So I put here plus 0.3 FBC sin 40. For the dy, dy is going to rotate clockwise, so plus dy 0.3 here. Okay, then for the dx, the dx also has tendency to rotate at clockwise direction times the distance 0.4 plus 2.5 and equal to 0. Then the answer is negative 4.16 kilonewton, or we can say that the rotation of the moment is opposite with my assumption that positive to the clockwise direction. So the answer is 4.16 kilonewton meter anti-clockwise rotation.
Thank you, Haiqal. Assalamualaikum. My name is Muhammad Hakim bin Basir. Now, I will do the analysis for the next system in the excavator, which is the bucket. As we can see here, there are 3 points of forces that acting on the bucket. First, we have point D here. Next, we have the two force member, which is at point A here. The point A, it is connecting the bucket and the arm. The last one, we have the weight point here. Bear in mind that we only have value dy and FAB from Haiqal's calculation before. We have FAB equal to 24.16 kilonewton in tension, while we have dy value is 16.87 kilonewton. Firstly, if we want to do the analysis, we need to take out the FBD for each point. We got point A here and point D and weight point. So here is the FBD that I take out from this. I transfer to this point D and point A. Then we can apply equation of equilibrium or EOE based on the dimension we get from the internet, because we don't have the dimension. So the dimension I take from Google and I got this dimension. To do the analysis, we need to plan our strategy to how to solve the moment at D here, so that we can know which direction that the bucket is will going, clockwise or anti-clockwise. So in these cases, after we analyze and plan our strategies, so because we have forces AB and dy value, so the first one we need to do is do the summation of fx. Summation of fx equal to 0 according to equation of equilibrium. So we assume that forces that going rightward is positive. So the equation will be dx plus FAB cos 85, because here we have 85 degree of forces at FAB equal to 0. Next, dx, which is unknown because we don't have the value yet. So we insert the FAB value, which is 24.16 cos 85 equal to 0. Next, we have dx equal to negative 2.11 kilonewton. Going right is positive. So because we get the answer is in negative form, so we can say that dx equal to positive 2.11 kilonewton going to the left. That means this forces is going to the left in tension. Next, because we get the dx, next we need to do the fy, summation of fy. Summation of fy equal to 0 according to equation of equilibrium. So this time we assume that upward is positive. So the equation will be like this: dy plus fab sine 85 minus the weight here equal to 0. Next we enter the value of dy, value of fab, and then we got the answer for weight. We got the answer for weight is 40.94 kilonewton downward. So after we got dx and w, we have all the forces in the bucket system. The next one, what we can do is we can do the summation of moment at D. This time, summation of moment at D, we assume that counterclockwise is positive, the equation will be summation moment at D equal to W times 0.3, not here, 0.3 here, 0.5 minus 0.2, we get 0.3 plus FAB cos 85, FAB cos 85 times 0.3, 0.3 here, plus FAB, FAB sin 85 times 0.2. We insert all the data and then we get total moment at D equal to positive 70.72 kilonewton meter. So because we got the answer in positive, so we know that the bucket is counterclockwise. The bucket will move counterclockwise. So for conclusion, frame or machine are structures that similar to trusses, except they have at least one member that is multi-force member. Multi-force member is an independent piece of system that has multiple of force that acting on it. Multiple of forces mean that it has more than one forces that acting on it. So frames and machine. What is frame? Frames are rigid structures that consist of several members that connected by pin. Generally, frames are stationary and it is not moving and have support from external loads. While machine, in other hand, machine are non-rigid structures that used for transmit forces. It contain moving part, and machine are designed to alter the effect of forces. Lastly, how to analyze forces on frames and machine. First, we analyze the figure and then we took out the FBD for each point. We took out the FBD, we draw FBD on the frame or machines and its member. Next, we can apply equation of equilibrium or EOE to get the unknown value. So we need to decide what we're going to do first, summation of Fx, summation of Fy, or summation of moment. Roses are red, violets are blue. Thank you.